Got it, right? So these two lines are like just to include a PIC.h and as defined this frequency you are setting. Okay. And then you have a global variable I is initialized with the 0, and you have a like this what is this function? Interrupt service routine. Okay, so for interrupt service routine, this name you can keep any name. There is no like a particular thing that you want to keep only this name, but only the expected thing is like the void and interrupt keyword should be there to indicate that this is a interrupt service routine. So void interrupt, and the name can be any name. And here you have a, what is this? Timer 0 interrupt flag. So that flag equal to 1 means you are going and you are just incrementing this I value and you are making the flag to 0. So here already we discussed like for any interrupt there is a interrupt flag will be there. So since we are using timer 0 interrupt, so the timer 0 interrupt flag is made to 1. And that flag, like if it is equal to 1, you are just counting that I as I incrementing the I, and you are making the flag to 0, and again you will come back to the main function. I hope everybody clear with interrupt service routine. Okay. Now coming to main function, here you are using the timer interrupt. Nothing but you are setting 10 millisecond, right? Okay. So here actually this is for 10 millisecond. You are trying to generate the delay 10 millisecond. So the load value for 10 millisecond. Okay, I'll come to that. Sir, how are you saying it is 59? All that I will come. Just understand the overall story. So 10 millisecond we are trying to generate the delay, so that you are giving 59. And then the option register you are making it to 0x07. What is the configuration we are doing in the option register, that also I'll come. Okay, these two lines I will explain later. Now the purpose of this project is like the purpose of this experiment is in RB2 you are going to connect one LED. In RB2 you are connecting one LED. That LED you are going to make on for 1 second and off for 1 second. That's the experiment of this particular one. So the RB2 you connected LED. So RB2 channel you want to configure. So you are configuring the RB2. Clear? You forget about these two lines. Here like a GIE, PIE you need to enable for any interrupt. Got it, right? And the timer 0, so TMR 0 interrupt enable you are making it as a 1. Clear? So this line I hope everybody clear. These two lines we are going to discuss, and this line everybody clear. Got it, right? So now you are coming to the while loop. Now once you are coming in the while loop, here just like a loop is keep running. When I value is 0, you are making RB2 as a RB2 is equal to 1. So RB2 you are making it as a 1. It means LED will be on. So you are making LED on, and here it is going I is 0 condition false. I is 0 condition false. Again it will be coming. Again I is 0, LED will be on. Condition false, condition false. So like that the loop is keep running. Loop is keep executing. Got it, right? So when it is keep executing, whenever 10 millisecond time happened, the purpose of timer is what? Whenever 10 millisecond happened, there is an internal interrupt will be triggered. Got it, right? So when internal interrupt is coming, that particular interrupt flag will be set to 1. Again, what interrupt we enable? We enable timer 0 interrupt enable. Again, for what time? 10 millisecond we enable it. So every 10 millisecond once the control is here, from there like the interrupt is triggered, so that particular flag will be set to 1. From here control will go to the interrupt service routine, and it will execute this, and again it will come back to the main, and again it will be keep running. Again after another 10 millisecond interrupt is triggered, it will execute this, again it will come back, again it will be keep running. Everybody getting the flow? Okay. So every 10 millisecond once the interrupt is triggered, and it will go to the interrupt service routine, it will execute, and again it will come back to the main while loop, and it will be keep executing. Got it, right? So from I value 0 to I value 99, got it, right? The LED will be on. Got it, right? You can take 100 times I value 100 times like the LED will be on. So I value, how frequent we are incrementing? Sorry? I value we are incrementing. When we are incrementing, whenever interrupt happens, we are incrementing. When the interrupt will happen? Every 10 milliseconds once interrupt will happen. So I value from 0 to 1 it is going means 10 millisecond over. From 1 to 2 it is over 20 millisecond. 2 to 3, 30 millisecond. Got it, right? So when it is reaching 100 into 10 millisecond, correct? Correct, right? So I value is reaching 100 means 100 into 10 millisecond. Every one I value is 10 millisecond. Everybody getting this logic, right? So 100 into 10 millisecond is 1000 millisecond. Got it? This is just a simple max, not related to anything timer and all. So 1000 millisecond time the LED will be on. That is nothing but 1 second LED will be on. Now when I value is reaching 100, so it will go here and RB2 is made to 0. Again from I value 100 to I value 199, the LED will be off. I value when it is reaching 200, you are again resetting the I value to 0. 0 means again it will go here, I value is 0 now, again it will make LED on. Clear, right? Very simple. When I value 0 to 100, making the LED on. When I value 100 to 200, making the LED off. Again you are resetting the I value, again 0 to 100, making LED on, 100 to 200, making LED off. So it is a 100 interrupt, 100 interrupt. Each interrupt is 10 milliseconds. So we are logically calculating and we are making the LED on for 1 second and off for 1 second. Is this clear for everybody? This is not related to timer. This is just a basic maths. Clear, right? So 100 count like we are making the LED on, and 100 count we are making the LED off. Each count is like a 10 milliseconds, so that like a 1 second LED will be on and 1 second LED will be off. Clear, everybody? So it is internal interrupt. It is internal interrupt. You see here we are not giving interrupt from anything outside. The interrupt is triggered within the microcontroller itself. How it is happening? Since we enabled that particular interrupt, we configured the interrupt to happen every 10 milliseconds, so that the interrupt is automatically every 10 millisecond interrupt is happening. So that this is a one example for internal interrupt, or also called as a software interrupt. Software interrupt means programmatically we are doing that interrupt. Boss, I'm configuring every 10 millisecond you give me interrupt. Like that I'm doing the configuration so that every 10 millisecond the interrupt is happening. Clear, everybody? Okay. So this overall exercise is clear. Now only pending thing is these two lines we don't know. Rest all I think everybody clear. What we are doing here and how the timer is like a used to calculate to make the delay generation. Clear, everybody? Okay, good. So now coming to prescaler. Already I given the overall logic what is prescaler. So prescaler, a prescaler divides down the clock signals used for the timer, giving the reduced overflow rates. What it getting right? So when like you are keep counting in one single register, it will be keep incrementing and there is a overflow will happen. After 255 when you increment, it will overflow happen, again it will reset to 0. Correct, right? A 8-bit register, you are keep incrementing, when it is going to 255 it is okay. Again 255 when you increment, it will reset to 0. Overflow will happen. So in that case like you are trying to reduce that overflow with the help of the prescaler, because you are trying to manage with the how many number of like clocks. Whenever it is reaching some certain clock, then only you are counting. Getting right? So whenever it is reaching like a for example 100 clock, you are counting 1. 100 clock, you are counting 1. 100 clock, you are counting 1. So that when it is reaching 500, your count is 5 minutes, you reach the 500 clocks. Everybody getting right? No need to count 500 times. So just you are counting like a 500. Every 100 you are counting 1, so that like when it is reaching 5, it means like a 500 clock has expired. Okay, that's the internal logic. So that's how like you have to relate. So divides down the clock signals used for the timer, giving the reduced overflow rates. There are different ways of definition is given, but core logic you understand accordingly, like you take any definition. Now this prescaler you can set. It means what ratio you want that in count. Every 100 clocks you want to count 1, or every 200 clocks you want to count 1, or every like a 2 clocks you want to count 1. Like that you can set that prescaler. So using this option register, okay, there is a one register called option register. In this there are some more parameters that we are ignoring it. Okay, I am not mentioned this because that's not related to this exercise. So PSA stands for prescaler assignment. So the prescaler is a separate component, timer is a separate component. Getting right? So this prescaler you want to assign it for this timer. For that, this bit you want to make it as a 0. So this bit you want to configure it to 0. If you configure it to 0, prescaler assigned to timer 0 module. Now, sir, I am making this as a 1. What will happen? So prescaler is assigned to WDT, not for timer 1. It is assigned for WDT. WDT stands for watchdog timer. Okay, what is watchdog? That and all you. That's a different story that we are not going to discuss. That's a different mechanism. Okay, so timer 0 is one module, WDT is one module. So this prescaler is one module. This prescaler, whether you are assigning for WDT or you are assigning for the timer 0. That's the concept. So now our experiment, like we are trying to use it for timer 0. So we are assigning it for timer 0. That's all. What is WDT, that and all we'll discuss later. Clear everybody? So prescaler can be assigned to WDT as well as can be assigned to timer 0. So if it is 1, it is assigned for WDT. If it is 0, it is assigned for the timer 0. So we are assigning it to timer 0. Clear? Next, there is a 3 bits. So using this 3 bit only, what ratio this prescaler has to work? That we are going to decide. Okay. So PS0, PS1, PS2. Okay, maybe this order you take. This is PS0, PS1. This is PS2. Okay. PS0, PS1, PS2. If all these 3 bits are 0, 0, 1:2 ratio the prescaler will work. After every 2 clock, it will count 1. Getting right? If it is 0, 0, 1, 4 clocks once it will count 1. If it is like a 0, 1, 0, 8 clocks once it will count 1. 0, 1, 1, 16 clocks once it will count 1. Like that. Clear everybody? Getting that ratio right? So already in odd bit we discussed. Every 72 odd bit you are counting 1. Here like a how many clocks once like it will count 1. I hope everybody following this. Okay, good. So prescaler, everybody clear? So we are selecting the prescaler. Prescaler we are assigning for timer 0. Also we are setting the prescaler. What ratio the prescaler calculation should happen? That we are setting using this 3 bits. So we are taking the maximum one. So we are configuring 0, 1, 1, 1. All 3 bits we are setting to 1. So it means what is the prescaler? 1:256. So every 256 once it will increment to 1 value, like that. Clear? So prescaler part everybody clear? So procedure for timer delay generation, set the timer prescaler in option register. So in option register we are assigning the prescaler and we are setting the prescaler as well. One job is done. So this one is done. Clear? Next, calculate the load value for record time and update the timer 0 register. You need to calculate the load value. So how are you going to calculate the load value is, for that you have a formula this. Time delay is equal to 255. Why 255? The timer 0 is the maximum value is Pressure. Okay. So why 255 here is 255. I mean timer 0 is a 8-bit register. So in 8-bit register, what is the maximum value? 255. So that maximum value minus your TMR 0 into prescaler into machine cycle. Okay, this is the formula. So now, what is machine cycle? First of all, we will understand. The prescaler, we know prescaler is we selected 256. So this will be 256. TMR 0 is unknown value. That only we are going to calculate. Clear? TMR 0 only we are going to calculate. And the time delay like according to our program, what is the time delay we want? 10 milliseconds we want. So this is 10 millisecond, this is unknown value, this is 256, and here one more unknown value is machine cycle. What is machine cycle? Already I told in the first day class, there is an instruction cycle or machine cycle or like a clock cycle. Okay, instruction cycle, machine cycle almost similar. Okay. Coming to machine cycle, what is clock cycle, what is machine cycle? Everybody forgot. Clock cycle, time period. Time period that is clock. What is machine cycle? One instruction. Okay, very good. So to complete one instruction, listen, okay. Anyway, I'll explain. So to complete one instruction, it needs 4 clocks as a bare minimum. Correct, right? What is that 4 clock? One is fetch, decode, execute, store. That's what 4 clock we discussed, right? So one machine cycle is nothing but 4 clocks. That is the reason it is 4 clocks. For 1 clock, what is the time in this controller? 1 clock is equal to 1 divided by 20 megahertz. For 1 clock, how much time it will require? So 1 second divided by 20 megahertz. If you solve this, we will get the time for 1 clock. So one machine cycle is 4 divided by 20 megahertz. Is it right? Correct, right? Because 1 clock means, one machine cycle is 4 clocks. So 4 into 1 divided by 20 megahertz, there is nothing but 4 divided by 20 megahertz. So this is nothing but 200 nanosecond. Okay, if you solve this 4 divided by 20 megahertz, if you solve this, you will get a 200 nanosecond. It is nothing but to execute one instruction, we need 4 clocks. For that 4 clock, how much time it is required is 200 nanoseconds. To execute one instruction, roughly we are calculating it is 200 nanosecond time is needed. Clear everybody? To run one instruction. So now you solve these all parameters in the formula. Time delay, how much we want? 10 millisecond. 255 minus TMR 0. TMR 0 is unknown value. Prescaler is 256 into 200 nanosecond. That's all. So now if you solve this problem, you will get the TMR 0. Okay, you guys solve it, no problem. So if you solve this, you will get value 59. That is nothing but your load value. Clear everybody? Okay. So that 59 only you are setting. So 59 you are setting to TMR 0. That is, this 59 is for this particular prescaler, this particular time is 59. Suppose same prescaler, sir, I have like a 15 millisecond or like a 20 millisecond, then the load value will be different. Suppose same 10 millisecond delay you want, but your prescaler is like a maybe 1:32. Then the load value will be different. Correct, right? Based on your prescaler, based on your like the time delay, this load value will be generated. And again your controller is different controller also, this load value is going to be different, because in this controller the frequency is 20 megahertz. In PIC controller itself there are some controller which works in like a 40 megahertz, then the load value is going to be different. I hope everybody able to relate. Okay, so calculate the load value for a record time and update the TMR0 register. So using this formula, we are calculating the load value. The load value is now it is 59. So that 59 we are setting. And also we are setting the option register. I hope everybody able to understand how the option register is becoming 0x07. Clear? And rest all already we discussed. Clear everyone? Okay. So timer is nothing but, as we discussed, timer is a counter which will be keep counting the clock. Based on the clock, it is going to generate the delay. Whenever the delay is happened, it is going to raise the interrupt. What time you are setting, 10 millisecond or 15 millisecond or 1 millisecond, accordingly it is going to generate the delay. So how it will notify to us, boss 10 millisecond over? How the microcontroller is informing us, boss 10 millisecond is over. Sorry? I think you already lost the context. So here microcontroller is doing some job. 10 millisecond over means what will happen? Interrupt is coming now. See, it is a concept called timer interrupt. What is the role of the interrupt here? Boss 10 millisecond you are setting, every 10 millisecond you will raise interrupt. Getting right? How it is not, see, I am setting alarm for 6 o'clock in the everyday morning. How the alarm is intimating me? It is making noise. Correct, right? That's how like I got to know, okay, 6 o'clock happened, every time I go. Similarly, your program is working in some different way. It is doing some job. How it is getting know that the 10 millisecond happened, it is getting interrupt. Okay? So that it is going to the interrupt service routine and doing the job, and then it is coming back. Okay? So timer is notified the delay with the help of the interrupt. So once interrupt is coming, according to your application, you are doing some necessary job and you are coming back. Clear? Okay. So as I already mentioned, the program is very simple. Nothing like a complex with the program, nothing complex with your circuit. Circuit is very simple, just you are connecting one LED. So the concept is like you need to focus. So later I will explain about this formula and all, because today itself like I feel like it may be overrated. So later I will come to this formula. Okay. But today you just understand what is counter, how the counter is working, what is like internal interrupt, what is the external interrupt. Yesterday we discussed. Just relate and try to make it clear what is prescaler and the prescaler role, how it is happening here. Clear? Everybody? Any question? Okay guys, fine. That's all for the day.